Okay, so here we are, and I'm going to start this by adding a cylinder. So I have my 3D cursor perfectly centered, press Shift A, create a cylinder, and then I have to scale the cylinder down, of course. Maybe like this, R, Y, and 90. And then I'm going to scale it out a little bit. So let's say that should be roughly the shape of my cylinder. And I'm going to shade it smooth. And if you shade smooth a cylinder, which does not have a subsurface modifier, you might start seeing kind of like a funny artifact like this. And that is because we have a very sharp edge, and Blender should render it smooth, and you can't render a sharp edge smooth, so we have to break this smooth shading. So I'm going to add an Edgesplit modifier. And you see the flat surface is flat and the round surface is nice and round. So let's say this is roughly our cylinder, and now I would like to generate a space so that this, for example, could be cut out. Technically speaking, all we probably need would be a path going up and then having this round shape. So I could actually duplicate the cylinder, and then I press Control I. Control I means it reverses your selection. So everything is selected besides the cylinder I duplicated, and I press H so I can hide everything conveniently. And then let's take a look at the cylinder. So what I'm going to do is first I'm going to delete those faces because I don't need those. And from a side view, I'm going to select all those lower points, and I have to do it to everything, so there, and delete those as well. And then I'm going to add 2 edges, because now if I select all these points and press F, I can fill that space, and the same here, fill. And then maybe this lower part I could fill as well. Because the reason why I did this is I have now half of a cylinder with a flat center part. In this one I can press E and then press Z and move it down. And that, for example, then visualizes the tunnel for our axis to come in. So let's bring everything back. So I press Alt H. And this one might not be long enough. And then I could, for example, rotate it. Let's say like this. And actually, our object is 22. 22 should be 23. Or actually 24 was correct. Or looks parallel. Okay. I'm going to give this object a new material, and I call it Boolean axis. And for example, make it orange. Because what I would like to do now is I'm going to select my fork, go to the modifier, I'm going to generate Boolean. And Boolean is similar like the shell command inside alias, where you can take 2 volumes and then calculate them together. So volume A could be joined to B, could be cut out to B, or you could have the common space of A and B together. In our case, we would like the difference. So I say difference, and this object, for example, also here I call Boolean axis. So in here, I can just simply type in Boolean, and then there it finds that object. Click it. And then I can move this one on a different layer so I don't see it all the time. And there you see now that Blender actually uses that volume of that part and then cuts out the space out of my bike. And also here again, you see along the edges, there are some shading artifacts. So after the Boolean modifier, we can also add an Edgesplit modifier. And if you would like to visualize the cut section better, we can add a secondary material. And then, for example, here we have Boolean axis. And there you see now that this shading material is being applied to my model wherever a surface from the Boolean object would be. And that, of course, is a task we do not finalize in Blender. So never hit apply Boolean, because if we go into wireframe mode, you can see that there are a lot of triangles here. That's really bad geometry. But this is already sufficient enough to get an idea about, for example, do I have here and here actually enough material for my axis? Because you don't want to discover this when you bring everything into Alias. But this part, for example, we can simply also export into Alias, generate the NURB surfaces. So we rebuild this in NURBS, and then trim it with the fork NURB surface. So, and that's basically then the way how, for example, we can create the pathways for our axis parts to fit in.